Hello, this is Mr. Collier, and today we're doing definite integrals. They have lots of applications. For example, the area under a curve from a to b is equal to the integral, and it also has some applications in kinematics and things like that. But we'll explore those applications later. For now, you just need to know that the definite integral from a to b is just f of b minus f of a, where those are the integrals. Okay. A and b are called the limits of integration. So let's do an example. Let's do the example number 2 here. So we're going to find the integral, and then we just plug in the values of -1 and 0. So let's find the integral. It's 3 over 1 minus 2x. So that's going to be ln absolute value of 1 minus 2x. And there's a 3 here. There's a constant of 3 that I could take outside the integral, so it's here. And by chain rule, if I differentiate, I get a -2, so I have to have it divided by -2 here. There's no plus c here because I will be evaluating this from -1 to 0. If I have a plus c, this is going to be a plus c and then a minus c. It'll just cancel each other out. Okay, so then I'll just do, I plug in 0, so I'll do I'll do it over here. -3 over 2 ln absolute value 1 minus 2 times 0 minus -3 over 2 ln absolute value of 1 minus 2 times -1. Okay, that gives us, well, ln of 1 is 0, so that term is gone. So we have 3 over 2 ln, this is 1 plus 2, so it's ln 3. So it's 3 over 2 ln 3. Okay, next we have this function. We're going to rewrite it first as 3 times 4x plus 1 to the power of half. Rewrite it as an exponent. Okay, this is a linear factor, so we can integrate this easily. We can just increase the exponent by 1. Okay, that means, well, we got a 3 in front, but we have to divide by 3 over 2, which is the same as multiplying by 2/3. We also got a 4 here, so we have to multiply by 1/4. Okay, I'm going to evaluate that from 0 to 2. Okay, 3's cancel here. We're just going to have half times 4 times 2 plus 1 to the power of 3 over 2 minus 4 times 0 plus 1 to the power of 3 over 2. Okay, so this gives us 9. 9 to the power of 3 over 2 is square root of 9 cubed, which is 27. And this is going to be 1, and 1 to the power of anything just gives you 1, so you're going to have half times 26, which is just 13. Okay, next example, we want to rewrite this first as, well, let's split it up into two integrals. 1 over root x minus the integral of 1 dx. Root x divided by root x is just 1 from 1 to 4. So this is the same as x to the power -half minus integral of 1 dx. So we'll increase the exponent by 1, then we have to divide by half. Evaluate that from 1 to 4, and this is just x, evaluate it from 1 to 4. So we're going to have 2 times root 4 minus root 1 minus 4 minus 1, or plus 1 is going to be minus -1. Okay, so that's going to be 2 times, this is just 1, minus 3, so it should be -1. Okay, next one we have a trig example. So let's integrate. The first term is easy. It's going to be x cubed over 3. The second one we call the derivative of tangent is secant squared, so that's just going to be tangent. And we have to divide by a 2 because of this one, so it's going to cancel that 2. So it's going to be tangent 2x. And we evaluate this from -pi/8 to pi/8. Okay, so that's pi cubed over 8 cubed times 1/3. Then you're going to have minus, and then you've got -pi/8 cubed times 1/3 plus tangent 2 times pi/8 minus tangent 2 times -pi/8. Okay, so here if you simplify all that, you get pi cubed over And I'll use my calculator. You get 768. And over here, and that's just pi over 4, and tangent pi over 4 is just 1. So you have a plus 1. Tangent is an odd function, so tangent negative pi over 4 is equal to negative tangent pi over 4. So you're going to have a negative negative 1, just like a plus 1. So you're going to have pi cubed over 768 plus 2. Okay, in the next example, we need to recall that, let me erase a couple things. Next example, you need to recall that the integral equals the area under the curve. So you can think about that to help you solve some of these, or you can think about the definition of a definite integral to solve them. In this one, you're going to get the integral of f, let's call it capital F, and plug in 3, and then you're going to subtract capital F of 3, so obviously that's going to be 0. This one's going to be negative 8. It's reversed because you would get the integral and evaluate it at 1 minus the integral evaluated at 5. So that's obviously the opposite of doing this one here, so you're going to get the opposite, which is negative 8. This one you can bring 3 out front, so 3 times negative 4 equals negative 12. And this one here, you can subtract these numbers. It's going to be 6 minus negative 4, which is 10. And this one here, you can split into 2 integrals, so we have both of those. So the integral of f of x is 6, and minus the g of x one is going to be 8. So that equals negative 2. And here you can do 4 times the integral of f of x, which is 6, minus the g of x, so that's 24, minus 8 is 16. Here you can do the integral of g of x, which is 8, plus the integral of 6 is just 6x, evaluated at from 1 to 5. That was 8, plus 6 times 5 minus 6 times 1, which is 8 plus 24, which is 32. Now this one is where we really need to think about the area, actually. This is a horizontal translation to the right 3. Okay, so if I translate this thing to the right 3, then the integral from 4 to 8 is the same as the integral from 1 to 5 of the original function. So that's just equal to 8.